Okay, hi everybody. You want to say hi?
Hi.
Yeah, there you go. It's just almost bedtime, so I forgot to make this video, so I'm gonna make it really quick. Does that sound all right, Sadie? Okay, so I said today I was going to make a video going over how to find the turning points, the local maximums or minimums, because we didn't get to it in the notes. Basically, a turning point, some might call it an extreme value, is basically any local maximum or minimum. So looking back at our notes, like what we did earlier, any of these, like this would be a local minimum, x to the third would have a local maximum and local minimum. Here would be a local minimum, local maximum, local minimum, local maximum, local minimum, local maximum, local minimum. Okay. Now, we talked about it being okay. So if you call the degree n, there's n minus one turning points. So n minus one extreme values. So like a degree of 5 has 1, 2, 3, 4 turning points. Degree of 4 has 3 turning points. So if you call the degree n, it has n minus 1 turning points or extreme values. Now, it's super easy to find out what they are given a calculator. So while I said portions of this test will be a no calculator, being like a red calculator per portion, this would have to go on the graphing calculator portion. So let me show you what to do here. You would just get out your calculator and go into y equals. I click y equals there, and you plug this 2x to the third, 2x to the third minus 18 x plus 1. I plug that in, and I'm going to zoom 6 to put it on my standard window. Now, you have to be able to see them on your screen to actually calculate them. So what I'm going to do is I'm going to zoom. Let's see if zoom fit will do it. You got to kind of manipulate your calculator a little bit. Am I making a funny face? Zoom fit. Oh, hair got on my face. To see if, oh no, zoom fit didn't really work. Let me go back. Zoom 6. Let's try just, see, I know my my extreme value based on what it looked like. I know there has to be one like up here, and I know there has to be a turning point down there, because if it's an x to the third power, it's got to have 2 turning points. So maybe I should just like expand out the top and the bottom. Like if I go to my window, I can make my y maximum, I don't know, let's just go crazy. Let's say 50. And my y minimum, negative 50. And c, negative 50. And let's see if that'll do it. There we go. And now I see both turning points. Now, to actually calculate them, here's what you do on the keystrokes. You go second, calculate, and look, you have a minimum and maximum. Now, this first one's going to be a maximum value. So we choose choice 4, and then it's going to ask you 3 questions. Left bound, and you have to trace over until your cursor goes to the left of the bump. And then you trace over until it goes to the right because it says right bound. And then what it's going to do is going to test out at y values to see which one's the biggest in between there. And it says, okay, the maximum value is going to be, some people might say that the maximum value is only 21.7. You could say that the maximum value of the function is 21.78, and it occurs at negative 1.73. So it just kind of depends on how you want to say it. I'll say the maximum value of the function is 21.78, local maximum, and then it occurs at negative 1.7. We know there is another extreme value there, and it is a local minimum point somewhere down here. So we just go second calculate, and now instead of maximum, I choose minimum, choice 3. And now again, it's going to ask me a left bound, so I trace over to somewhere to the left of the valley. I trace over somewhere to the right of the valley, hit enter, and then I go somewhere in the middle and I guess. And it will give me the lowest point. Coincidentally enough, it does occur at positive 1.73 for my x value. I kind of drew on that. It does occur at positive 1.73, and it is negative 19.78. So you would say that the minimum value of this function, the local minimum value, is negative 19.78, and it occurs at 1.73. Cool. So it's pretty easy. Just plug it in your calculator, manipulate your window so that you can see where the maximum minimum points are, and then you go second calculate maximum, second calculate minimum. left bound, enter, right bound, enter, guess, somewhere in the middle, enter, and it'll spit out the answer for you. The y value is truly the maximum or minimum value of the function, and it occurs at the x value. Okay. All right, that's it, Sadie. You want to say bye-bye?
Bye.
You ready to go to bed? You ready to go to bed? You ready to go to bed? All right, see you, everybody.